the first question in section A about odd and even numbers. Well, which of the following results in an odd numbers? Well, as you can see that for the odd number, actually you need to know some rules, like how can we get an even number, how can we get an odd number? Well, basically when it comes to subtraction or addition, I think you should be very familiar that, you should be very familiar that even plus even, that is always an even, right? And also even minus even, that is always an even. Then what about the even number plus an odd number? Yes, you will get an odd number. Then what about the even number minus odd number? Yeah, that is also an odd number. Even though you just shifted the position like odd plus even or odd minus even, then you can also get even. So if you know the basic rule, let's move on to the question. Well, you see that for the first one, this is the odd number times the even number. So here, pay attention that in multiplication, even number is super powerful. That is, as long as there is one even number, okay, the final answer must be even. So here for the first one, you can confirm it should be even. Then for the second one, it is the odd number plus odd number. Well, odd number plus odd number, actually you can just pair them up. Pair them up, then you will get an even number. Okay, so here also cancel. Well, next one, it is the even number minus the even number. And just as I showed you, here you see that the answer should be even. Okay, and the last one, okay, pay attention to the division part. Well, you see that this is an even number. Even number divided by even number. Is the answer must be even? Actually, no. Let me just show you a very easy example. What about the 12 divided by 4? 12 divided by 4, that is 3, right? So actually, you see that when it comes to the division, you need to double check. So here, everyone actually can just calculate what is 312 divided by 24. Well, the answer is 30. So that is why for the first question, we choose D, okay? Well, following this for the second one, it takes 4 men 18 days to clear 1,200 meters square of woodland. How many days will it take 12 men to clear 2,400 meters square of woodland? Okay, so actually this question is about the rate. I think for students, if you join the TASMO or you are preparing for GP, I think such topics should be very easy for you, right? So here, let's have a look. When it comes to the rate problem, you should be very clear of 3 elements. The first one is about the worker. The second one is about the timer. And the last one is about the outcome. So here you can see that both worker and the time will affect the outcome. Then following this, let's try to write down, the relationship here. So we know that according to the question, 4 men, 18 days, and then we get 1,200. Then following this, what are we looking for? We are looking for 12 men, 2,400. So here, everyone, you see that what is the relationship between the workers here? Well, from 4 to 12, that is, we just multiply by 3, right? Okay, then what about the outcome? Yes, from 1,200 to 2,400. So here you see that times 2. Then the question is times 3. But how can you result in times 2? Well, here, let's have a look. In the middle part, what should we do? Well, you see that maybe we try to cancel the odd number 3. So what can be cancelled with times 3? That is, if you divide by 3, right? So here, let's write it down. But following this, you see that actually what is your target? Your target is to times 2, which means here you need to times 2. So following this, let's do the calculation. What is 18 divided by 3 and then times 2? Actually, that is 6 times 2, which is 12, okay? So for the second one, we choose the answer C. Well, following this question 3, super easy, but please read the question carefully. How many more, okay? Some students just count the number of triangles or only count the number of squares. Okay, pay attention. The question is asking you the difference between these two parts. So how many triangles are there? Of course, we just start from the small triangle, right? So here you see that we have 1, we have 2, 3, and 4. Then following this, let's have a look. Maybe you can try to combine some smaller pieces to get a bigger triangle. For example, if I just combine 2 smaller triangles and 1 square, then I can get a bigger triangle. Then this is 1 And then let's move on. Here we have 2. And then following this, we have 3, right? Okay, so here, plus 3. Then following this also, maybe we can just include more smaller pieces to get an even bigger one. So here we have 1, okay? And then we have 2. So again, plus 2. But can we just stop here? No. So you will see that actually for the whole figure, that is a big triangle. So based on this, we just plus 1. So actually, how many triangles are there? You will get 4 plus 3 plus 2 plus 1. The answer is 10. And then following this, what about the square? Well, when it comes to a square, also we just count from the smallest to 1, which is 1 by 1 square. For 1 by 1 square, how many can you see? We have 1, 2, 3, 4, 5, 6, right? So here we have 6. But following this, do remember that after 1 by 1, you need to move on to 2 by 2. How many 2 by 2 squares are there? Yes, so here you see that for the corner part, right? So here, plus 1. Then, back to the question, how many more? Well, 10 minus 7, you will get 3. So here, this is answer. We choose C. Okay, 3 more. Then, following this for question 4, Danny is 35 years younger than Justin. And Justin is 8 years as old as Danny this year. How old will Danny be in 9 years? Well, for this question, usually we start from the multiple part, right? When it comes to age problem, especially when you can see that there is some sum, difference, and multiple. So here, we always start from the multiple part. Well, if you draw the model, you will see that here for Justin and Danny. Justin is 8 times as old as Danny. So here, Danny should be 1 unit, which means Justin should be 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And also, if you can just find it easier way, maybe you just label the first one 8 unit, the second one 2 unit. Then you don't need to draw out so many rectangles, right? And then, what is the meaning of 35? Is it for Danny's age this year? No, that is for Danny is 35 years younger. So actually that is the age difference. So what is the age difference? Well, you see that 8 unit, 1 unit, of course. Difference is 7 unit. 7 unit equals to 35, so 1 unit equals to 35 divided by 7, which is 5. Then can we just say, okay, I choose 8? No. Why? Because again, who is 5 years old? You see that Danny this year 5 years old, but the question is asking you how old will Danny be in 9 years? So based on 5, what should I do? That is 5 plus 9. So here the answer should be C. Okay. Yeah, read the question carefully. Okay, in 9 years, that is 2 plus 9. Okay, then next one. 6 weights weighing 1 pound, 2 pounds, 3 pounds, 4 pounds, 5 pounds, and 6 pounds respectively were placed into 3 boxes. Well, you can see 2 weights in each box. Well, we know that the 2 weights in the first box weigh 9 pounds altogether, while for the second box, that is 8 pounds together. So what is the total weight? In the third box? Well, we know that the total is 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? So what is the total? Yes, the total is 21 pounds. And then for the first box and the second box, you already get 9 plus 8, which is 17 pounds. Which means for the third box, you can only see 21 minus 17, which is 4 pounds. Then following this, could you please tell me which 2 numbers will add up to 4? Yes, there's only one choice, which is B, right? 3 plus 1, that is 4. Then next one, question 6, the 5-digit number 2018U is divisible by 9. What is the remainder when the number is divided by 8? Well, firstly, you see that what is the question telling us? The number is divisible by 9. So what is the divisibility of 9? Yes, if a number is divisible by 9, you need to make sure that the digit sum is divisible by 9. Then let's check what is the digit sum. For the digit sum, that is 2 plus 0 plus 1 plus 8 plus u, right? So what can you get? Good job. That is 11 plus u. You need to make sure that 11 plus u is divisible by 9. And also pay attention, letter u must be a single digit. So what is the possible value of u? Correct. U equals to 7. Okay, so back to the question. What is the number here? Actually, that is 20187. And when you back to the question, what is the remainder when this number is divided by 8? So here, for the number divided by 8, you will get the answer. It should be 2523, remainder 3. So what is the answer? We choose B. Okay. Again, for this question, it is not that hard. You just need to be clear about the divisibility rule of 9. And then check the question. What is the question asking you? It is for the remainder. Okay, and then for the next one, question 7, this is about the logical reasoning. 4 brothers named A, B, C, and D have different heights. They state the following. A said, I am neither the tallest nor the shortest. B, I am not the shortest. C, I'm the tallest. D, I am the shortest. So exactly one of them is lying. Who is the tallest? Okay, so here, let's assume one by one. Well, altogether, you will see that there are 4 people. Okay? And then, if A is lying, let's have a look. If A is lying, I am not the tallest or the shortest. So if A is lying, that means A should be the tallest or the shortest, right? But then think about it. If A is the tallest, then he will be conflicted with C. Cannot. If A is the shortest, then A will be conflicted with D. Also cannot. So actually you see that A cannot be the liar. Then what about B? If B is the liar, let's have a look. B said, I am not the shortest. But if B is lying, then B should be the shortest one. But can B be the shortest one? Cannot. Why? Because D is the shortest one already. So again, B cannot be the liar. Then what about the C? C said, I am the tallest. So if C is the liar one, which means C cannot be the tallest. If C is not the tallest one, maybe C is the second one, maybe C is the third one, maybe C is the shortest one, right? And then let's try to analyze one by one. A said, I'm not the tallest or the shortest. So again, you can only put A in the middle. B said, I'm not the shortest, which means here for B, you can put it for the first 3 places. Then D said, I am the shortest. Okay, good. Now we can confirm D is the shortest, so cannot be C. And here, everyone, you see that according to all these possibilities, now you see that who is the only one that can be the tallest one? Only B, right? So here, let's write down B. Then what about the 2 positions in the middle? Actually, maybe A, maybe C, right? For these 2 people, we cannot confirm. So maybe you just arrange that in this way, or you just put C and A like this. So in this way, actually, you see that there's no conflict. So who is the tallest one? It should be B, okay? And also here, let me show you, how come D cannot be the liar? Okay, let's have a look. D said, I am the shortest, but if D is the liar one, then D is not the shortest, which means D, I can only put it like this. Then C says, I'm the tallest. Okay, now we can confirm C. B said, I'm not the shortest. So here, B can only be in the middle. A said, I'm not the tallest or the shortest. So actually, you see that for A, also in the middle. So actually, you see that there is something strange. If D is the liar, then no one is the shortest one, right? So that is why actually for such question, the only possible way that is C is the liar, and then B is the tallest one, okay? Now, following this for question 8, Ada has 14 gray balls, 8 white balls, and 6 black balls in a bag. What is the least number of the balls she has to take out of her bag, having her eyes closed to make sure that she took at least 1 ball of each color? each color. So think about it, which color should we start from? If you are the unluckiest person in the world, then you have to take more balls, right? So here you see that which color has the most balls. Yes, that is the gray one. So now let's start from 14 and then move on to the white, plus 8. And then plus here. As long as you get one more ball, so actually you can get every color, right? So based on this, we plus 1. Then the answer is 23. We choose 8. Okay, then question 9. Seko writes the numbers 15, 16, 17, 18, 19. After he erases one of the numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase? Well, of course, for such question, you can just try one by one. For example, if I erase 15, okay, so what is the sum of the rest number? You can try 16 plus 17 plus 18 plus 19, and then is the result divisible by 4? Okay. And then following this, you can try, okay, what about I erase 16? Then you will see that, okay, 15 plus 17 plus 18 plus 19, you add them together, is the result divisible by 4? And then following this again, let's move on. Okay, if you erase 17, then what about the sum of the rest of 4 numbers? It is divisible by 4. But actually, we have a faster way. Okay, let me show you, everyone. Firstly, let's try to analyze. For these 5 numbers, you can see that. Is 15 divisible by 4? No. So what is the remainder? Okay, good. The remainder, that it should be 3. Okay, so here 15 divided by 4, you get a 3, remainder 3, right? And then following this, what about 16? Yes, 16 is divisible by 4, so there's no remainder. What about the 17 divisible by 4? Yes, remainder 1. And next one, what about the 18? 18 divisible by 4, okay, remainder 2. And then following this, remainder 3. So another easier way for you to figure out the answer in a faster way, that is, we just try to analyze the remainder. Well, you see that for 16, there's no remainder. So actually 16 is a very good number in this question. But what about the 15? Well, you see that we have 3 remaining numbers. And as long as I get one more, actually you can see that we can try to make sure that the sum is a multiple of 4. So maybe we can try to pair up 15 and 17, right? Okay, but after this, you will see that, what about the 2 and the 3? Actually, you still have 5 numbers as the remaining. You cannot just erase 1 to make sure that the number is divisible by 4. So in this way, again, what should we do? Actually, now that is how can you erase 1 remainder and make sure that the rest part that is divisible by 4. So now everyone, you see that any faster way. Well, for such thing, actually you can see that, again, for 13, for remainder 3 and remainder 3 and remainder 2, altogether, what can you get? Well, you see that for this remainder, we have 3 plus 3 plus 2, which is 8. Is it divisible by 4? Yes, right? 8 divided by 4, that is 2. So actually, you see that which one will be the actual one? The actual should be 17. So that is why we get the answer, that is 17. This is the faster way. Yeah, also let me explain more, okay? Just as what I show you. Yes, why can we just pair up R3 and R1? For example, back to the original number. 15 plus 17, what can you get? That is a 32, right? So actually you see it's a 32 divisible by 4? Yes. Why? So actually you see that we just do with the remainder. If you can pair up the remainder, then you can make sure that the sum is divisible by 8. So just back to the question. Now you see that what did we do just now? We pair R3, R2, R3. So here you see that for this part, we get 8. 8 is divisible by 4, which means the 3 numbers will add up to a number that is divisible by 4. Okay? Then next one, question 10. Question 10 is about the additional and multiplication principle. Well, 4 colors are used, not necessary to use all, to paint each part of the figure below. If the colors in adjacent parts cannot be the same, How many ways of painting are there? Well, for such question, everyone, think about it. Which place is the most special one? Which place is the most special one? Yes, the middle one. Why? Because you will see that for the middle part, it is adjacent to all the other areas, right? So here, when you try to find out how many possible ways, we always start from the most special place. So think about it. For the first place, how many choices are there? Altogether, there are 4 colors. Of course, we have 4 choices. Okay, for the middle one. Okay, let me write down. For the middle one, there are 4. Then, following this, let's have a look. There are also 2 special places. Let's have a look. Maybe I label it as area A and area C. Why? Why are they special? Well, according to the question, we know that it is not necessary to use all colors, which means some colors can repeat it, okay? But why do we start from these 2 areas? Well, you can see that for each of them, they have 3 adjacent areas, right? Okay, so now, following this, let's have a look. You need to consider 2 cases. For the first one, that is, what about if A and C, they have the same colors? Okay, then let's have a look. If they have the same colors, just now we know that for the middle one, we have 4 choices. And then what about for A or C? Yes, we have 3 choices. But for the other one, it must have the same number, right? So here, 1. If you just, for example, if you just paint A as the pink one, then C must be the pink one, right? So there's only 1 choice for C. Then, following this, what about the other 2? For other 2, think about it, altogether we have 4 colors. And then you just use 2 colors, which means we still have 2 choices. Then following this, we have 2 and 2 for the 2 question mark areas. And then following this, we just multiply them together. So you can see that in such case, how many possible ways to paint? That is, we have 48. Okay. And then following this, what about the second case? If I already show you the first case is A and C have the same color, then the last one, okay, so you will see that they are the different color. And then if they have the different colors, then what about the number of possible ways? Again, we know the middle one gets 4. Then following this, okay, let's move on to A. For part A, how many colors you can choose? Yes, you use the 1, so you still have 3 choices. And then following this, what about the C? Okay, following this here for C, you only have 2 choices because they are the different colors, right? And then what about for the rest of the part? For this part, actually you see that you already used the 1, 2, 3 colors, which means there's only 1 possible way for you. And actually the same logic works from the other side. Here, how many choices you have? You already used the 1, 2, 3 colors. So there is only way for you to paint the star part. Okay, so here, what is the second part? That is here we have 24 ways. And do remember that for the last step, you need to add these 2 cases together. So what is 48 plus 24? Yes, you will get 72. Okay. So this is for the section A. I think section A should be still very basic for you, right? Okay, and then let's move on to section B. Section B, visitors to an exhibition hall can enter and leave the hall using 8 different doors. How many ways can a visitor enter and leave the exhibition hall using different doors? Actually, this question very easy. Think about it. You have 8 doors to choose. So actually, how many ways are there for the entrance? Yes, 8, right? And then following this, you must leave in a different door. So how many choices you have? 7. Then you just multiply them together. So you can see the answer should be D. Okay, 56. Yes, and the next one, question 12. Granny has 10 grandchildren, each with a different age. Alice is the oldest. If the sum of all the grandchildren's ages is 180, what is the youngest age that Alice can be? Well, for such question again, let me emphasize some key points. Ali is the oldest one, and you try to figure out what is the youngest age of the oldest child. So actually the question is asking you what is the minimum of the most, right? Okay. So here, everyone, you see that. Of course, the son is 180. Then Alice could be very, very old, right? And then also could be a bit older. So what is the youngest one? That is, you try to make sure that the age difference between these grandchildren is as small as possible. You try to make sure that the age difference is as small as possible. So what should we do? Okay. So firstly, maybe we can try to figure out the average. So here for the average, that is 180 divided by 10, which is 18. But can all the children just be 18 years old? No, they must get a different age. So here, let's have a look. How can we change these numbers? Okay, let me just show you there are 10, 18. And then you will see that to make sure that the difference is as small as possible, that is all the numbers should be very close to 18, right? So in this way, how can you make sure that the gap is very small? Here, maybe you just plus 1, you minus 1. Plus 2, minus 2. Plus 3, minus 3, right? As you can see that 10 is an even number. So here, let's start from the middle. Here, plus 1, minus 1. Plus 2, minus 2. Plus 3, minus 3. Plus 4, minus 4. Plus 5, minus 5. So you can see that what is the youngest age that Alice can be? Yes, can only be 23, okay? So you see that actually the age are consecutive numbers. In this way, the gap is only 1, right? So 1 is very, very small already. You cannot get a half a year, right? Okay, so in this way, we can get the minimum of the most in this question is 23, okay? Then next one, question 13. This is about the fraction. Yeah, so far any question? Okay, so you can see that this is about the fraction. I think such questions should be very familiar to many students, right? Okay, now let's have a look. What is the pattern? We know that 1/3, then move on to 1/2. But pay attention. Maybe if you cannot find, we just skip it, okay? Let's move on. Then we have a 5/9. Then we have a 7/12. Well, everyone, you can try to observe. Can you find some pattern? Well, for me, usually I just guess. Like, okay, 3, 9, 12. Wow, they look like the multiples of 3, right? So what is the missing number in the middle? If I want to get some multiple of 3, yes, the middle one should be 6. And then let's check. What over 3? What over 6? Then that is the equal as 1/2. Yes, that is a 3/6. Wow, maybe that makes sense. Okay, now let's double check. So following this here, the next multiple of 3, it should be 15. And then let's have a look. Can we turn 3/5 into something over 15? Yes, that is 9. So following this, I think now you can try to find the pattern. Well, for all the denominators here, they are multiples of 3, right? So what is the next one? You just add another 3, which is 18. And then following this, what about the numerator? 1, 3, 5, 7, 9. What is the next one? Yes, it is 11. So here we always plus 2. So actually this answer should be 11/18. Okay. Yeah, for such question, it is also about the equivalent fraction. Okay. Yeah, equivalent fraction, that is the fraction has a different numerator and denominator, but actually they refer to the same value. Okay, then question 14. There were some pieces of candy in a bowl. Sally added some pieces to candy. some pieces of candy to make the number of pieces in the bowl 2 more than twice. Okay, think about it. How do we show 2 more than twice? We always start from the multiple part. So here, again, we always start from twice. And then after that, Clara took 3 less than half of the remaining pieces. Well, everyone, you see, for such question, apart from these numbers, also pay attention to the 2 words. The first one is about added. The second one is about took. And then in the end, we know that there were 16 pieces. And the question is asking how many pieces of candy were in the bowl at the beginning. Well, here you see that we know the process. A child added some candies. A child took out some candies. And also we know that in the end, how many candies are left? We try to figure out the beginning. So what kind of question is this? That is called a working backwards, okay? For the working backwards, you always know the process and the ending, but you don't know what is the beginning. Then following this here, let's try to draw out the train diagram. Okay, there are some candies. Then firstly, added 2 more than twice. Added, so here times 2, then plus 2. Then following this, took 3 less than half. Took 3 less than half. So firstly, divided by 2. And then, do we really took half? No, that is a 3 less, right? So actually, if you took half, you took more. You need to return 3 candies. So that is why, plus 3. Then in the end, we know that the answer is 16. Now let's try to think backwards. 16 and then minus 3, you will get 13. 13 times 2, you will get 26. 26 minus 2, you will get 24. 24 divided by 2, you will get 12. So that is why the answer is 12. Okay, then question 15. Dylan and Linda are picking apples. Dylan says, if I give Linda 7 of my apples, then she will have twice as many apples as I do. Linda says, if I give Dylan 7 of my apples, then he will have the same apples as I do. So Linda picked how many apples? Well, here everyone, you see that according to these 2 statements, okay, maybe we start from the Linda one. Why? Because we know that if Dylan gives 7 of my apples, if Linda gives Dylan 7 apples, then they will be the same, which means what is the difference between the number of apples here? Yes, it should be 14. Because if you give 7, then you have the same. Now you see, you give 7, the other person plus 7. So then to make the same number, which means the original difference should be 7 plus 7, which is 14. Okay. Well, then following this, let's move on to the first statement. Yeah, okay. And then let's move on to the first statement. Let's have a look. How can we draw out the model? Dylan and Linda. Okay. So here, according to the question, we know that Dylan says, I give Linda 7 of my apples. Okay, so here, let's cancel 7. Then she will have twice as many apples as I do. So here, let's draw it out. This is for 1 unit, and then we draw another unit. Okay. But for these 2 units, okay, again, remember that actually there are 7 apples from Dylan. So this part is also 7. And also here, let's have a look. For the original part, we already know that the difference is 14. So which part is 14? Now you see, before Dylan gave the apple, before the Linda received the apple. So we know that the difference here, it should be 14. Okay. Now, following this, what can we figure out? Well, according to the model, you can see that for 1 unit, actually we can divide it into 3 parts. So what is the 1 unit here? It is 7 plus 14 plus 7. Then the answer is 28. But the question is not asking you what is the value of 1 unit. The question is asking you, Linda picked how many apples? So what should we do? Yes, you can get for 2 units, that is 2 times 28, which is 56. But that is after Linda received 7, right? So actually, again, everyone, you see, for the last part, you need to pay attention. Before Linda received the 7. So how do we show before? Minus, okay? That is 56 minus 7. Then you can get 49, okay? So this is answer. How do we get 49? The answer is D. Okay. Yeah, next one, question 16. A bug is moving from B to A along the lines as shown below. It can only move downwards or leftwards, and it cannot pass through C. Cannot pass through C, then you can just take C as 0. Okay, there's no way, right? No way, 0. What is the total number of different paths from B to A? Well, from B to A, so here we can just try to label. From B to the next point here, well, you see that there is only one way, right? So we just label 1. So for the same logic, what about to the point at the bottom? So here we get 1. Then what about this one? Yes, we have 2 different ways, so that is 1 plus 1, which is 2. Okay. And then following this, actually you can just try to label out all the points. But pay attention, point C, you need to regard it as 0, which means, okay, let me change another color. How many points can you reach the green point? Well, if you want to reach the green point, can you just reach it from the right side? Cannot. Why? Because 0. No way. Okay. So following this, you see that only one way, which means for the green part, actually here, only 1. Okay, only one possible way. Then following this, let's have a look. What about the next? Okay, let me label. What about this purple point? Okay, for the purple point, think about it. How can you reach the purple point? That is, maybe you move from the top, maybe you move from the right. So here, 1 plus 1, we can get 2. Okay. So again, for the same logic, you can just add all the points for the rest part. So now you see that about this one. Yes, we have 3, and this one we have a 4, and this one we have a 5. Then following this is this one. Again, 0 plus 3. Okay, so that is still 3. And then following this we have 7, and then following this we have 12, and then following this we have 4 and 11 and 23. Okay, and then 6, and then 17. So what is the final answer? The final answer, you see that we have 17 plus 23, which means 14. Okay. Then next one, question 17. The perimeter of the figure is, okay. As you can see that now, I know that many students try to use the push-out method, right? But then you are very confused, right? Because actually, we don't know. Yeah, we don't know for some part. Maybe you try to push out here. We have a 6, and for this part, and then you push out to the top. Yeah. I know that some students try with such method, and also here today, I want to show another method with you. Okay, let's have a look. Here we call it as the direction marking method. Direction marking. Okay, so for the first part, we just find the starting point. For example, I start from here. And then let's have a look. In order to get back to the original place, so here I need to move up, move right, down, up, right, down, left, right? Okay, and then again, since you can go back to the original place, which means actually for the opposite directions, you must move for the same distance, right? Just like, okay, if I'm standing here, then I go to the right side for 10 minutes. I want to come back, so what should I do? Yes, I must turn to the left side by 10 minutes. And then for the same thing, how can we figure out the perimeter by such method? Well, let's have a look. For the total distance, we move to the right side. It should be equal to the total distance we move on to the left side. So move on to the left side, you see that where is the side? Can you find it? Yes, that is the 12th one. Which means the left one, 12, that is the right one, also 12. Then following this, what about the up and the down? Well, for the top, okay, maybe some students say that, okay, look, I don't know what is the length of this side. Also, I don't know. Oh, for this side, that is 6. But what should we do? Okay, maybe try to find another way. Okay, here, pay attention. All the sides with the downward arrow. With the downward arrow, now you see we have a 3, we have a 6, and then we have a 3. So could you please tell me what is a 3 plus a 6 plus a 3? Yes, that is a 12, which means for the upward, also 12. Okay. Now, what is the perimeter? Yeah, for perimeter, it is 4 times 12, and then you will see that the answer is 48. 48 centimeter. Is it hard? Should be okay, right? Okay. And following this here, it is for question 18. Question 18, it is known that a rope wraps around a big tree 9 times with 4 meters left. If the same rope wraps around the tree 10 times and falls short by 1 meter, how many meters are left if it wraps around 8 times? So here, everyone, you see that actually for the length of one circle of the tree, it doesn't change. And also the total length of the rope, it doesn't change, right? But we just rope for different times. So here, let's have a look. For the first case, maybe I just set for the one circle of a big tree, that is for 1C, okay? Okay, one cycle. And then following this, what about the 9 times with the 4 meters left? That is after you try it for 9C, and then you still have 4 left. That is a plus 4. And then following this, for the same rope wraps around the tree 10 times. 10 times, so what can you get? That is 10C. But it is short by 1 meter. So what is the meaning of short by 1 meter? Yes, that is a -1. Okay, that is not enough. And then you see that here, the total length of the rope, actually it doesn't change. So what is the sign in the middle? Yes, equal sign, okay? So this is how we build the equation. And according to such equation, can you figure out the value of C? Okay, yeah. You will get 9C plus 4 equals to 10C minus 1. So 1C equals to 5. Again, what is the meaning of 5? Yeah, that is the length of one circle. Okay, one circle, that is 5. Okay, let me write down here. Equals to 5 meters. Then following this, the question is asking you how many meters are left if it wraps around 8 times. Well, for 8 times, we already know that for 1 time it will be 5 meters, so what about 8 times? Yeah, that is 5 times 8. And also, can you figure out what is the total length? Can you figure out the total length of the rope? Well, actually here we have 2 different ways. That is, maybe you use, 9 circles and then plus 4. Or 10 circles minus 1. Okay, both are correct. Then we can get 9 times 5 plus 4, which is 49. Okay, or you can just use 10 times 5 minus 1, that is 49. So you see that what is the remainder? Yes, we just figure out what is the gap between 40 and 49. Then we have 49 minus 40, which is 9 meters. And this is answer 9 meters. Okay, next one, question 19. Well, question 19 is super easy. There are 20 teams in the soccer league. Each team must play exactly 1 match with another team. And then how many matches are to be played altogether in the league? As you can see that here, if you are playing the game, of course you cannot play with yourself, right? You must play with other people or other teams. So here, if there are 20 teams, think about it for the first team, how many games they need to play? Yes, 19, right? So here we can get 19 and then plus 18 and then plus 17 and then plus 16 and then plus 15 and then plus until the last 2 teams, okay? So following this, actually you see that it is like a arithmetic sequence. So how do we do? Just use the formula. Yes, we have 1 plus 19 and then times 19 and then divided by 2. So what is 20 times 19 divided by 2? The answer is 190. Okay. Next one, question 20. In September of a particular year, there were exactly 4 Mondays, 4 Wednesdays, and 4 Fridays. On which day of the week was the 1st of September that year? Wow, my first question is, how many days are there in September? How many days are there? 31? Are you sure? How many days are there in September? Okay, good. 30, right? You can just look at hand. Huh? So you see January, not here, January, February, March, April, and then May, June, July, and then August, and then September. September, so now you see here, 30 days. Then this is for the first one. And then let's have a look. When it comes to a month, actually we can confirm that definitely there will be 4 whole weeks, right? So here let's try to draw out a mini calendar. 1, 2, 3, 4, 5, 6, 7. And then we can confirm there must be 4 weeks. 1, 2, 3, 4, and then, yes, and then we have 29 and 30. Okay. Then you can see that there are 4 Mondays, 4 Wednesdays, and 4 Fridays. Do you know how come I draw a dotted line in the middle here? Yes, I try to separate it into 2 parts. On the left side, you see that for all these days, you can see it for 5 times. But on the right side, for all these days, you can only see it for 4 times. So where should we put a Monday? Well, Monday, Tuesday, Wednesday, Thursday, Friday. So here, I must put them on the right side, right? So here, you can write down Monday, Tuesday, Wednesday, Thursday, Friday. Okay, question, what is the next one? Where's my Saturday? Good job. Saturday should be at the very beginning. So here, we have a Saturday and a Sunday. So after you draw out the calendar, then the rest part, wow, super easy. Which day is the first day of September? Now you see it is Saturday. So that is why for the answer, we just write down 6. Okay. Yeah, finally, section C. Section C, many students complain that to me. Wow, teacher, Apple is so hard, right? Okay, but actually for question 21, I think it should be okay. Yeah, 21 is still okay. Okay, let's have a look. It is a number puzzle, but it is a bit tricky as you can see addition and subtraction at the same time, right? So what should I do? As long as it is the number puzzle, we just turn that into the vertical form first, okay? So here, let's write down as A4 4 plus 6 2B plus equals to box, 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 okay? We try to split it. And then following this, we know that box, box, box minus 8C2 equals to 7, 7, right? Okay, then for this part, should be easy. Now you see that actually we can find some digits that can be confirmed. Well, let's start from the 1's digit. For the 1's digit, what can you confirm? Yes, you see 7 plus 2, right? 7 plus 2, that is 9. Okay, so this is 9. Well, at the same time, we just filling 9 here. Okay, so now you see 7 plus 2, that is 9. And then which letter can we confirm? Well, if you know that this is a 9, then you see 4 plus B, that is 9. So what is B? Yeah, B equals to 5, right? Super easy, right? Okay, and then for the next one, what about the 10th place? For the 10th place, for the right side, I don't know what minus C, that is 7. But what can you confirm? Yes, 4 plus 2, that is 6, which means the middle one should be 6. But, everyone, is 6 enough to minus something and then you get 7? Cannot. So what should I do? Yes, you must borrow, right? So actually this is 16 instead of just 6. Okay, then 16 minus C equals to 7. Then what can you get? Okay, let me write down. Yeah, 16 minus C equals to 7. So what can we get? C equals to? Yeah, C equals to 9. Okay. Then following this, what about the 100th place? For the 100th place, yes, for the 100th place, well, which one is easier for us to start? Is it A plus 6 equals to box? No. Why? Well, actually, you see that the box minus 1, then you minus 8. Look, there's nothing. Wow, what is it? Very easy, right? That is 9 minus 1 equals to 8. So here we can get this one should be 9. This is 9. Also the hundreds place here, it should be 9. Then following this, we know that a plus 6, that is equal to 9, which means a equals to, equals to 3. And then, please don't tell me, okay, final answer 359, super easy. No, what is the question asking you? That is the sum of a plus b plus c. What is a plus b plus c? 3 plus 5 plus 9. The answer is 17. Okay, so 17 should be the final answer. Easy? Okay. Question 22 is a bit hard to understand. What is the question talking about, right? Well, let's have a look. There are 2,024 people standing in a line from front to back. Some are wearing red hats and some are wearing blue hats. Those wearing blue hats always tell the truth. Those wearing white hats always lie. And then each person can only see the hats in front of them. Then the host asked each person, how many red hats can you see among all the answers given by the children? Each number from 0 to 2023 appears exactly once. And the question is asking you what is the minimum possible number of red hats in the line. So firstly, everyone, you see, for such question like a truth or lie, okay, we always starting from the truth part. So think about it. What kind of people that always tell the truth? Yeah, the one wearing blue hats, right? So here, everyone, think about it. Can we just put two blue hats people together? Cannot. Why? If you put them together, actually, they will tell you the same number, right? For example, okay, if there is only one red hat in front, okay, so here, the blue one will say, 1. The other blue one also say, 1. But actually, according to the question, we know that there are so many different numbers from 0 to 2023, which means there cannot be two people wearing the blue hats together, right? So in this way, we know that what is the minimum possible number of the red hats? They must be next to the blue one, right? So here you can get something like this. Okay, red, blue, something like this, right? Okay, so now you see that at least you will see one red, one blue, one red, one blue. So altogether there are 2,024 people. How can you find the half? That is, you just divide it by 2. Divided by 2, then you can get 1, 0, 1, 2, and this is the answer. Yeah, and also, for example, the first one, okay, the red one say, okay, I can see 0. And then the second one, the blue one, okay, blue one just, sorry, I used the wrong color. Okay, for example, the first one, red one, the blue one said, okay, 0. There's nobody wearing the red hat in front of me. And then the second one is the red one. The red one maybe say, okay, so here I can see 1,012 red hats in front of me. Oh, of course, liar, right? And then the next one, again, the blue one say, oh, now I see 1. And then the red one say, okay, I see 1,013, right? And then following this, again, the blue one say, okay, now I see 2. And then following this, the red one says, okay, I see 1,014. So now move on, you see that what about the last part? It is still the blue one. Blue one always tell the truth since it is half. So here I say, okay, I can see 1,011 red hats in front of me. And then the red one just say, okay, I can see 2,023 red hats in front of me. So you see that this is only one possible arrangement. Okay. Then next one, question 23. Well, this is also about the working backwards, but it is a bit tricky. 3 adventurers explored a forest together. They found it boring on the way, so they played cards together. In the first game, A lost to B and C, causing the winner's money to double. So here, everyone, let's write it down. Here, A, B, C. Okay, A lost to B and C. A minus something, while B and C double. So here, B and C times 2 times 2. Then in the second game, A and B won together. So the money in their wallets double. Okay, so here let's have a look. A double, B double. Okay, which means C lost something. Okay, minus minus. Then in the third part, A and C won the money. So here A and C can double. What about the B? Okay, B will lose something. Okay, so here minus. Then in the end, they all have the same amount of money in their hands now. And then A counted the money in his wallet and found that he lost $100. Can you figure out how much money C had at the beginning? Well, how do we figure out the beginning part? Well, there is no number, right? So here, everyone, let's try to assume. As you can see that no matter it is A or B or C, they always times 2 times 2. So maybe we can just assume with some multiples of 2. Okay, I know that, for example, some students will guess. Okay, maybe I just assume every person gets 8 units of cars in the end. So following this here, we can try to think backwards. So here, 8 units divided by 2. What is it? Yes, that is 4 units. Also, 8 units divided by 2. C also got 4 units, which means for B minus how many units? B minus 8 units, right? So here, originally, B got 16 units. Then following this again, 16 units divided by 2, then you have 8 units. What about 4 units divided by 2? Yes, that is 2 units. So then you see from 2 to 4 plus 2, from 8 to 16 plus 8, which means C minus 10 units. So here originally, it should be 14 units. Then following this again, 7 units, and then 4 units, and then we have plus 4 plus 7, that is minus 11, which is 13 units at the very beginning. Then actually, I still don't have the exact number, but according to the question, we know that A counted his money and found that A lost 100 units. $100. Well, originally, A had 13 units. In the end, A only had 8 units. So you see that how many units of cars did he lost? Yes, so that is 13 units minus 8 units, which is 5 units. 5 units equals to $100, which means 1 unit is $20. Then back to the question. The question is asking you how much money C had at the beginning. C had 7 units, so 7 units equals to $140. So here, write it down. Okay. Then, okay, we still have the last 2 questions. Okay, good. So here for the next one, question 24. Anson and Jamie set off from A and B respectively, walking towards each other. Anson's speed is 3 meters per second, and Jamie's speed is 2 meters per second. Upon reaching B and A respectively, they immediately turn back and return to their original locations. If the distance between the first meeting point and the second meeting point is 300 meters, then the distance between A and B is. Well, here, everyone, let's have a look. For the distance, speed, and time problem, you always need to draw out the diagram first. So here, let's label, this is for A and this is for B. We know that there are 2 people. We have Anson. The speed is 3 meters per second. And then we have Jamie. The speed is 2 meters per second. So think about it. Where will they meet each other for the first time? Well, for Anson's speed, that is 3 meters per second. Jamie, 2 meters per second. That means when they meet each other, the distance that Anson walked should be 3 times. And then Jamie's distance should be regarded as 2 times, right? So here, to make it more clear, maybe we just split the road into 5 equal parts. So can you find the first point where they meet each other? So here, Anson move 3 units. Then Jenny move 2 units. Because they will start at the same time. That is, the time they traveled should be the same. So actually, you see that the relationship between their speed should be the same as the relationship between their distance. Okay, and then following this, let's label up. This point is for the first time when they meet each other. And after they meet each other, what should they do? They need to move on, right? They need to move on. And then when they reach the other point, then they just turn back. So here, again, let's have a look. For the next one, Anson move on. Another 3 units. And then you will see that for Jamie, okay, so here let me change another color, another 2 units. Okay. And then again, another 3 units. And then another 2 units. Okay. So what can you find? For the second time they meet each other, now you see that about this point. Then according to the question, we know that the distance between these 2 meeting points is 300 meters, which means actually for this unit, these 2 units, they will add up to 300 meters. Then what about 1 unit? Yes, 1 unit should be 150 meters. Then what is the distance between A and B? The distance between A and B, you will see that there are 5 units. So 5U equals to 5 times 150, that is 750 meters. Okay? Yeah. The last one, 25. In the figure below, CEDF is a square in triangle ABC. AD equals to 20 and BD equals to 10. What is the sum of the areas of triangles ADE and BDF? Okay, for these 2 parts, let me just highlight ADE and BDF. Okay, for these 2 parts. Well, what should we do? Around you see, according to the question, we know that there is a special square. For the special square, now we know that all the angles should be right angle. And also, all these 4 sides, they should be the same, right? So actually here, maybe we can try to imagine that. If we can move part of the shape. So here, maybe we can try to rotate DFB. As you can see that the DF equals to DE. And then there's always a right angle in the middle. So here, maybe I can try to draw it out like this. Okay. If I rotate it in this way, then everyone, let's have a look. You just pay attention to the triangle. Maybe I label it as point G, okay? So what about EGD? Well, these 2 parts should be the same. I mean the area of triangle DEG and the area of triangle DBF. Why? Because when it comes to the relationship of the side, they have the equal side as here ED equals to DF. And also for the size of the angle, they should be the same. Because here you see that for EDG plus GDF, that is 90 degrees. Well, also you can get the GDF plus FDB, that is also 90 degrees. So for these 2 small angles, they should be the same size, right? Okay, and then also here we know that this is about the part of the square. So here we also have 2 right angles. That is why actually we can confirm these 2 triangles, they should be totally the same. So following this, if they are totally the same, BD equals to 10, which means DG is also 10. So in this way, actually we find a way to combine these 2 parts together and form a bigger triangle. So how do we figure out the area of the bigger triangle? That is related to the formula of the area of a triangle. Base times the height and then divided by 2. The base is 20. And what about the height? Height is 10. So 20 times 10 and then to remember to divide it by 2. So what is the answer? The answer is 100. Okay. So actually this is the last question. To be honest, it is a bit tricky, right? Especially I know that most students haven't learned much about the triangle, especially the area and the angles of the triangles, right? Okay. But actually here you see when it comes to right angle triangle, as long as you can confirm that the 2 angles are the same size and also for one side, that is the same. So actually we can confirm the two triangles, I mean the right angle triangles, they must be identical. Okay.